Okay, this video is going to look at skin color and what kind of makes up the pigmentation for the different skin colors that we see depicted here. So looking first at skin color and the pigments, there's three main ones we want to focus on. First one is melanin, and this is the most important, provides UV protection. Now there's a delicate balance between being protected from UV light and being able to synthesize vitamin D. I have a separate video that handles light versus vitamin D, and you're welcome to check that out. The second type of skin pigment is keratin. This is provided from our diet. Could be carrots, yellow vegetables, tomatoes. These have a lot of keratin in them. Carrots, for example, beta-carotene you may have heard of. Hemoglobin's the last one. It's the pink of light skin. Caucasian skin contains little melanin, and it's actually some of the hemoglobin that's coming through that's giving the skin its color or appearance. Now we're looking at a map of the world here, and we could see different regions of the world tie in with the skin color. We'll notice areas that tend to be higher intensities of sun, where there's a large population, tend to have darker skin colors than at the North Pole, for example, here, where there tends to be less intense sunlight. So we could see that there's definitely correlation here, particularly in Africa and Australia, with the skin tone, the chromatic scale, and the relation to the equator, or the intensity of sun. We're looking at this as a genetic end of things, and we're looking at skin color is genetic. The intensity of the pigment is based on the amount of melanin, and that's genetically controlled. Light-colored skin is due to the connective tissue and hemoglobin giving it its light color. And as we saw before, geographic location and has a set amount of UV radiation, which correlates with the indigenous skin pigment, and is the average skin pigment for that region. Now, I did say skin color is genetic, which is true. We see that evident here, where we have a homozygous, basically recessive for all of the color genes here, light, and then all homozygous down here for very dark. And then we've got our heterozygotes here, we breed those here for our F2 generation, and we get this kind of effect here. Most out of resulting from this cross will be kind of that medium, in this case a scale of 3 skin color. 0 would be very as rare as number 6 here. And we can see that kind of also depicted here in a Punnett square like for a trihybrid cross. So again, it's genetic, we kind of have the ideas here, but with the geographic location being an influence on selecting for one skin type or one pigmentation versus another. So a little comparison between what we see, the macroscopic view and the microscopic view. So the photos show 40x magnification, and Caucasian skin here is A, and may not be able to see it here, but B is located right here. This is a microscopic version of the skin. And we see C here for East Indians, and then D is located here. E is located here for African Americans, and then F here. So if you're looking where these letters are located, the B, the D, and the F might be a little hard to pick out initially. If you note the progression increase of melanin as skin pigment darkens. And this is, you can check the links here, courtesy of someone who was able to provide these pictures online, and I'm using here to show you guys how what we're noticing is the melanin or pigmentation is darkening as our skin color is darkening. So what provides this? Well, the melanocyte location. This is what's producing the actual melanin, so melanin production. So here's our skin. Notice we're kind of towards the upper surface here, the epidermis and dermal layers. If we zoom in that box, it looks like this, and this is our specific zoom in of the melanocyte. To kind of tie it all together, here's our melanocyte down here. This would be dark skin on the left and light skin on the right, and we notice that there's a lot of these melanosomes that are dark. So melanin is the pigmentation, and these cells contain a lot of that, and that tends to be the darker skin. Here, the lighter skin, we see a lot of those are basically left white or blank. They don't have that pigmentation, and that will show up ultimately as lighter skin, allowing hemoglobin and connective tissue to show through. Here, with our intense melanin, we're getting that darker skin appearance there. Keep in mind, this is our high epidermis here. This is the skin cells that will be kind of leaving off and getting broken off and being shed. And this is our layer down here that's working its progression up here. Hopefully this provides you a little bit of a background on the pigmentation of different skin color.